Okay, so in this video we're going to be going over some of the compounds that were in your worksheet and your notes. So I'm going to start with the first part where you had written a question mark, and I'm going to explain how they're different from the page where you circle them in red. So remember, the first thing that we need to differentiate here is ionic compounds versus covalent compounds. Now, in your class, apparently you don't use the word covalent, you use molecular. Okay, so you have ionic compounds and molecular compounds. Now, let's kind of discuss how can you identify the differences between these two. Well, notice I'm saying in general, right? Not 100% of the time, but 99.9% of the time. When you're working with ionic compounds, you have a metal and a non-metal. So that's kind of the first thing you want to be looking at, right? When you see your compound, and I'll be using the compounds in your note packet as an example. But so metal and non-metal, and for molecular, we've talked about this before. This is strictly so non-metal and non-metal. Now, the reason why it's important to distinguish between these two is that the naming conventions are different. The naming rules, right, the nomenclature is not going to be the same for the two of them, right? The rules are different. So when you're working with ionic compounds, the rules are pretty simple. So you put the name of the metal. So you write down name of metal. And then you write the name of the non-metal, but you drop the last suffix and you add "ide." So name of non-metal. And then here I'll put drop suffix, drop the last syllable. Drop ending and add "ide," I-D-E. Okay, so this is going to be pretty much the same. The only time it's different is when the metal is a transition metal. And we discussed this in our session previously. We talked about what happens when you have a transition metal. And we have an example over here. I should probably just write it out because this is a good time to discuss this. So if you're given this compound CuCl2, first thing that we notice is that Cu is copper. We know that from the periodic table of elements. It's a metal, and it's in the transition block. So copper is a transition metal. Then Cl, looking at the periodic table, we know that it's chlorine. And it's important to know the charges, right? So the total charge, each chlorine ion is going to have a -1 charge. Now, how many of these atoms do we have? We've got 2 of them. So the total charge is going to be -2 of this chlorine part. Okay? So what that means is that you need to have 2 positive charges for the copper. So when you write the name, we're going to follow the rule. We're going to put name of metal, but right after that, we're going to write parentheses and put a Roman numeral 2 to indicate the charge. Copper needs to be +2 in order for the net charge, or the overall charge of this compound, to be 0. Because remember, we've got 2 chlorine ions, each one has a -1 charge. So you get -2 charge in total from here. So this needs to be a +2 charge in order for the complete overall charge to be 0. So that's why we put that Roman numeral 2. So it would be copper chloride. So again, we're following the rules for ionic when we're dealing with these ionic compounds. And of course, the rules are a little bit different when you have transition metals, because you have to pay attention to the charges, make sure you write the correct Roman numeral. Alright, so now we're going to go ahead and look at some of the rules for the molecular compounds. So I'll put them over here. So for the molecular compounds, we got to pay attention to the number of atoms that each element has. That's important because we're going to use those Greek prefixes, those Greek and Latin prefixes, right before the element when we name them. So let's look at some examples from your packet so I can pick how that, show you how that works. So the first one, when we use this one, is P, and then you have Cl3. Okay, so when the first element, right, only has one atom, then we just write its name. So it's phosphorus. There's only one atom. The second element has 3 atoms. That's what the little 3 subscript indicates. So we have 3 chlorine atoms here, and what we need to do is use our prefix, which is tri. That's for 3. You're going to have to memorize those. So for 3 it's tri, and then we're going to put chloride. So we're still using that suffix IED, IDE, for molecular compounds, but remember that for molecular they only apply to this one at the end, right? Alright, so phosphorus trichloride. Okay, let's go ahead and look at the second one here. So that's sulfur, and then we have F6. Okay, so again we write down the name of the first element, and we don't have to put any prefixes if it's 1, so it would just be sulfur. And then this is going to be fluoride, but there's a 6, so we have to put that hexafluoride. Okay, and remember, we're only using these rules here because these are molecular compounds. So just to reiterate, non-metal, non-metal, you need to be familiar with the periodic table of elements. You need to know where the non-metals lie, because that's what's going to help you determine if it's molecular. So phosphorus is a non-metal, chlorine is non-metal. Sulfur is a non-metal, fluorine is a non-metal. So that's what qualifies them as molecular compounds. Alright, so we already took care of that one. Let's go ahead and do the next one. So that's O, F2. Again, this is one atom of oxygen, so it's going to be just oxygen. And again, we're still dealing with non-metal and non-metal, so it's a molecular compound. So we're using the rules for the molecular compounds. So we have oxygen, and then how many fluorine atoms? We have 2 of them. So we're going to use the prefix for 2, which is di, and then we're going to write fluoride, difluoride. Notice all of the second elements are going to be ending in IED, so keep that in mind. Okay, pretty easy there. Let's go ahead and look at the third one. That's Cl. So Cl2 and then O7. Okay. So this one's a little bit different. We know that chlorine is a nonmetal. We know that oxygen is a nonmetal. So this is a molecular compound. And what's different about this one is the first element has more than one. So now the name is going to be slightly different. So we have to use the prefix for this one over here. So we have to put di, but I'm going to write chlorine. Okay, because that's the element. We're not putting dichloride. The IDE is only for the second element. Okay, so we've got dichlorine, and then this oxygen, we've got 7, so it's hept oxide. There you go. Dichlorine heptoxide. Okay. Now, be careful with the prefixes, because if you're looking at a list, let me see if I can pull them up here real quick. So you'll see things like the prefix will be like hexa, hepta, penta, but you have to be careful when you have, you wouldn't say like hexa oxide. So if you have like two vowels next to each other, it sounds weird. So we tend to drop the A, right? Because then it just sounds awkward, like heptoxide. That's nice versus heptaoxide, right? So that's just kind of a linguistic feature of this. Just kind of like not vowel harmony, but you don't want to add unnecessary vowels. Okay. So that one was that. And then we have SO3. Again, this is a molecular compound. Why is it a molecular compound? Because sulfur is a nonmetal, oxygen is a nonmetal. Okay, so there's only one of the sulfur, so I'm going to just write down sulfur. And then we have 3 oxygen, so it's going to be trioxide. Of course, we always add the IED. I keep saying that, IDE. Alright. So that takes care of the questions there. We can go ahead and look at the more practice ones. Let's look at those. So here we have, I'll go ahead and write them underneath. So this has CaCl2. Alright, so right off the bat here, I'm looking at this. I'm asking the question, is this an ionic compound? Is it a molecular compound? What in the world is this? Well, if you're looking at this, we have calcium, which is a metal, and we have chlorine, which is a nonmetal. Aha, so metal, nonmetal, that's a big hint. Big hint. We've got an ionic compound. So we're going to follow the rules that we use for ionic compounds. So I'm going to write down calcium, because we always write the name of the metal unless you have a transition metal. And we know from memory that calcium is not a transition metal. So calcium. And then we write our nonmetal, but of course we change the suffix. So calcium chloride. We change the ending, add that suffix. So those are relatively easier. You just gotta watch out for the ones that have transition metals. You gotta familiarize yourself with the periodic table of elements so you can identify those. For number 8, we have C and then Cl2. First question we ask ourselves, what in the world is this? Is it an ionic compound or is it a molecular compound? Well, C is carbon, that's a nonmetal. Cl is obviously chlorine, another nonmetal. Aha, we're dealing with a molecular compound. So that means we have to use the rules for molecular compounds. So we write the name of the nonmetal. And remember, there's only one of them, so carbon. If there were like 2, 3, 4, 5, then we'd have to put the prefix, right? The numerical prefix. And then how many of these chlorine do we have? Well, we've got 2 of them, so it'd be dichloride. So we're using again the rules for molecular compounds. So be careful with these problems. Make sure you identify which ones are ionic and which ones are molecular. Just for fun, we can do some more practice. Let's see. I'm trying to see if I can find here. You know what? I'll make a separate video, so I'll conclude this one now, upload it, and then I can make an additional practice video. Since here I'm only talking about the kind of the general concepts, right?